This is a video about drawing Lewis structures for compounds that have double and triple covalent bonds. So some elements, particularly these ones I have listed here, they can share more than one pair of electrons in a bond. So a double covalent bond would be when you have two pairs of electrons between two elements, let's say element X and element Y. And we can also show that, remember, each line is a single covalent, so we can also show that with, it kind of looks like an equal sign, but it's not. And then there's also times where we can form triple covalent bonds. So let's say I have X, so there would be 3 pairs or 6 total electrons shared between X and Y. And we would show it with 3 lines like this. This is a table just showing you the difference in bond length and energy. So as I go from a single to a double to a triple, the length of the bond actually gets lower. And the energy goes up, which means a triple bond is going to be the shortest. So the atoms will be closest together, and it's also going to be the strongest. It would take the most amount of energy to break it apart. So there are some atoms that will not form double or triple covalent bonds. I should have triple in here. And those are hydrogen and the halogens. And the halogens are group 17. Because remember, hydrogen just has that one electron, so it'll just want one more bond. And then the halogens, like chlorine, for example, has 7. So it only has that one unpaired electron. So it's only going to bond one time. But let's look at some where they will form a multiple bond. So I want you guys to pause the video and calculate the electron cache and draw the the single covalent bonds and subtract from the cache, and then unpause the video. So pause. Okay, so here we go. So carbon dioxide is CO2. So we've got carbon and oxygen. We have 1 and 2. Carbon has 4 valence. Oxygen has 6. So that gives us 12 and 4 for a total of 16 electrons is my electron cache. So now I'm going to put carbon in the middle, because carbon has the most unpaired electrons. I'll put the oxygens on the side. And now I've used up 4 total electrons, so I have 12 left. So now I would place them around the outside and then go to the inside until everyone has an octet. So I would go 2, 4, 6 here, because now this oxygen has 2, 4, 6, 8. So it is happy. And then I would place the others 2, 4, 6 around this one. And again, this oxygen now has 8. So the problem is I'm out of electrons now. I only had 12. And poor little carbon is not okay. Carbon is not okay with just 4 valence electrons. So what'll happen is oxygen is going to be nice friend and share some electrons with carbon. So right now carbon has 2, 4, 6, so he's still very unhappy. So we need to have the other oxygen share too. So let's double check. Let's take that frown and turn it upside down. Uh-oh, don't make it go away completely. But this carbon now has 2, 4, 6, 8 valence electrons. both of the oxygens still have 8. 2, 4, 6, 8. This guy, 2, 4, 6, 8. So everyone's good. Yay! So let's do a couple more. Here is one, and you can definitely try it before you watch me. Calculate the cash first. So I have 1, 1, and 1. 1 valence, 4, and I have 5, which gives me 10 for my cash. Carbon has 4 unpaired electrons, so I'm going to put carbon in the middle. I'm going to bond hydrogen. Once it bonds, it's done. And then I'm going to put the nitrogen over here. So now I've used up 4 electrons. So I have 6 left. And again, here's where you really want to follow. I'm going to go to the outside, and if I have enough, I'll go to the inside. I'm not going to put any electrons on hydrogen because it's already happy. It has 2, and it's plenty happy with that because it's just a little atom. So I'm going to go over here to the nitrogen. 2, 4, 6. And with this has 8. So nitrogen is happy, stable. But carbon is not again. So carbon only has 4, and that's not okay. So what we need to do is nitrogen now needs to share. So I'm going to take a pair and bring them over. So it's kind of like I don't know why it's not working. I'm rearranging. Whoa! Let's see. I may have to pause the video. Give me a second. Okay. So I'm going to take this pair of electrons now, and I'm going to bring them down here. So the nitrogen still has 8, 2, 4, 6, 8. Carbon now has 6. Carbon's still not okay. So let's try my eraser one more time. Yes, it finally worked. So I'm going to bring another pair of electrons from that nitrogen over. So now nitrogen, 2, 4, 6, 8, it's still good. Carbon, 2, 4, 6, 8, it's good. Everyone's happy. All right, let's keep going. So you'll see compounds like this. These are called hydrocarbons. And you still do everything the same. It's just that you don't really have a central atom. So I've got carbon and hydrogen. I have 4 and 8. 4 valence electrons, 1. So I have 16 and 8, or 24 total electrons. So we know that hydrogen can only bond once, so we're going to put the carbons in the middle. And then we're going to put the hydrogens around and make sure that the carbons don't end up with more than 8 valence electrons. I could put one here if I wanted. So I'm at 5, 6, 7, 8. And you could have put yours here and not on the ends, but it doesn't matter because you're going to use your eraser. So 1, 2, 3, 4, 5, 6, 7, 8. I placed all 8. Now I'm going to figure out how many electrons I have. So let's figure out how many I used up in my bonds. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So I have 2 electrons left to spend. And I'm going to erase this just so it's cleaner looking for you now. So I have 2 electrons only left to spend or place in this diagram. If I put them here, this carbon will have 8. This one has 8. This one has 8. This one here only has 6. So the question is, where do I put the 2? If I put them there, or if I put them here, then this one won't have enough. So this is the solution. You're going to not put them as a pair outside, but you're going to make a bond. So I'm going to make them into a bond here. And I could have put that bond in different places and it would still be correct. But let's check if that worked. So this carbon has 2, 4, 6, 8. It's good. this carbon here, 2, 4, 6, 8. This carbon still has 8, and this one still has 8. But I could have put that bond here or here, and then rearranged, just making sure that carbon only has 8, no more and no less. Resonance structures are compounds or ions that you can't really draw them with just one Lewis structure. You need more than one Lewis structure. And I'm going to show you one example of this. This would be the nitrate ion. If you want to try to draw it without me, and then pause it and then come back, that would be awesome. So I'm doing my cache. So I have 23 electrons, but remember it's -1, which means add an electron. If it were -2, we would add 2. I'm going to add 1, and then I get an even number of electrons, which is what I want. Then I'm going to put the N in the middle. I just spent 6, so I have 18 left. So I'm going to place them around in pairs on the outside, and then go to the inside if I have enough, or the central atom if I have enough. So 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm out. So the oxygens all have 8 valence electrons. The nitrogen only has 6. So I do need to make a double bond. I'm going to erase, and I'm going to put the double here. It's also an ion, so don't forget to put the brackets with the charge. But here's the deal. Resonance means this isn't the only structure. So I could have put the double bond here, and then, sorry, then I would have, it would look like this. Also, I could have put the double bond down there. And they're all correct. So all 3 structures are kind of needed in order to be able to describe this nitrate ion. I'm not going to make you draw all 3. I just want you to be aware of it, that you might have a little bit different structure than I do if you look at my answer keys or whatever. Also, resonance is the extra pair of electrons here, they don't really just stay there. What they do is they localize and they move around all of the bonds. We just can't really show that with a Lewis structure. So they're actually kind of like a 1.5, not a double, not a single bond between all of these. And it's something that creates things that are really stable.